Okay, hello everybody. We're going to go through how to analyze the sequence that we now have cleaned up. The sequences are um, all in the same direction, and so it'll make the analysis a lot easier. To do the analysis, you'll need several websites, and they're here in this handout that I will email to everybody, um, along with a link to this video. So you need these three websites at least, so the access to the sequence, uh, the the spreadsheet that has what we think is in each of the wells, and then the website called Target. And you'll see why you need each of these as we go along. You don't need this tab at this time. Um, So I've selected A1 from plate 1, and if we go over here to the varieties, it says that A1 and plate 1 is supposed to be Lux, okay, the gene Lux. So this means A1 through A6 means these columns, 1 through 6, and then a different gene should be in 7 through 12, and the same DNAs are repeated. So the DNAs in A1 to H6 is repeated A7 to H12. Okay, and then this was one primer set that is supposed to be Lux, and this is a second primer set which is supposed to be CHE, okay, on this side. And we can look down here and see the success of the sequencing, and it's not that great, but we got a lot of sequence, at least for these, and then sequences for the first few varieties, okay? And each of these represents citrus varieties found at UCR. And then the same is true for plates 2, 4, 5, and 6, and 7. Okay, and what I've done is gone through and on this tab down here, if you click on plates, what I've done is this is the counts again that you saw here. Um, here. And what I've done is assigned these to various students. Okay, everybody's got roughly the same number of sequences to look at, and you don't have to look at all 1800. I'll go through how many to look at in a moment. Okay, but the problem is I noticed as I was verifying my analysis, my cleaning up of the sequence, all the different scripts that I run the sequence through to get it so that it's usable, I noticed that when I searched on these sequences, so if I click this, I will get it in this tab here. Okay, when I put these in, it turned out it wasn't Lux. Okay, and then I blasted it against some other things, and I found that the sequence wasn't what it's supposed to be. So what I did was take all of the sequences that were used to design the PCR primers. I made a BLAST database. Okay, so and using Target with BLAST DNA query. Okay, here we have the DG clock. So it's like a very tiny BLAST database with something like 12 genes in it. And so what that's going to allow us to do is to verify or fix what sequences are in these different cells or wells. Okay, so what you're going to need to do is I said for each well, okay, or cell here, whichever you want to call that. So for A1, which is a particular gene and a different citrus variety, and A2, same gene but different variety, um, you want to take these 15 of these and blast them using this Target tool. And Target is something that I put together with a graduate student, and it does a whole bunch of stuff. We're just using it as a handy way to do a custom blast database and see what our sequence is. So you select the database up here, paste your query sequence down here, and just go to blast. Okay, don't worry about what the other stops mean. Okay, and here we get our result. It looks different than the other one, but all that means is that all these bases have very high similarity to some hits in the database. And here we go. So this actually turns up, if we look, this is old school BLAST. It's not going to be nice and pretty formatted like you're used to at the website, but it works. And so you're going to see that this particular one matches LHY1 and CCA1. Okay, and we'll come back to that. But and they're the exact same scores and the exact same E value. Then you get this little match here, but it's tiny. It's a 40 score. It's very small for GI. And if we scroll down through here, we'll see that this is it. And that's not a legitimate match. That is not useful at all. Okay, so with this, you can see, though, if we scroll through, this match is pretty good, and it's actually very good. And so is the particular one. Now, LHY and CCA1 are two different genes in Arabidopsis. Okay, they have different protein sequence. But when I blast each of those protein sequences against the citrus genome, it gives me the same region of chromosome 3. Okay, so chromosome 3 pulls up both times for LHY and CCA1, suggesting that they're the same gene in citrus. Okay, and it kind of makes sense because LHY1 and CCA1 are both transcription factors of the MIB type proteins, and so it's likely that they serve the same function. The same protein does the same function in citrus as two proteins does in Arabidopsis. But we'll go with that. So now we know that this is not, what did we say? This is not A1. It's not Lux. We know now that it is, in fact, CCA1. So what you're going to do is you're going to go in here and say CCA1 slash LHY1. Okay? And then, but you need to do that for 15 sequences. And for each sequence that you do, create a Google Drive document is fine for now. And save that sequence. Okay, so there we go. That's one sequence. If you want it to be nice and pretty, you go to Courier 9, and now it fits. Okay, and of course we need to make sure we call this document plate 1A1. Okay, so that's gonna hopefully become the name. There we go. So now we have that sequence, and then you want to go and do 15, and at least half of those, roughly half of those, should be one that's called RC. And let me find one here. There we go. So here's one that has the identifying number and then the letters RC. That stands for reverse complement. So that means that my software programs identified this sequence as being on the opposite strand. So it was the result of the reverse primer. So I have since then, instead of it being the reverse complement sequence to this, I reversed it so that it should be identical to this. So let me show you what I mean. Going in the same direction. So here's the output from the first one that I did. That one was a forward sequence to begin with, and you look, the query goes from 1332 to 1338, so it's increasing in numbers. So it's going in the same direction as the query here is going in the same direction as the subject, so it's the forward sequence. Okay, and so you can just simply click the back button, delete all that, paste in the new sequence, run the blast, and we'll take a look. Again, we get LHY, CCA1, very high scores, excellent. And again, we see that the query starts and is going up, so that means it's going in the correct way. So I managed to finally get all the bugs worked out, and all the sequence here is all going in the same direction. We don't have to worry about some being a forward sequence and some being a reverse. Okay, so we would want, then we verified that one, so we'll go down here and we'll paste it in. Okay, and when you do this, of course, make sure you have the comment, This gives us back to the original sequence that was came off the sequencer. So we need to document that. So when you have 15 of that one, then close this document and then move on to the next one. Okay, so then Kim would move on to this one and do as many. Now here there's not 15, so you would do all 9, all 6, just as many as you can if there's not enough to do 15. And in cases where there's just less than 5, ignore them. And in fact, I don't even think I assigned them. Right. So that's so Claudia, although these are 4, go ahead and do these. But then you can see here's everybody, and then we have everybody and Alicia Avecido got a set of sequences to do. So that's what you need to do for now. Once you have all of your the folder, what I'm going to do is I'll create a folder and share it so that we can paste all of our, oh, that's right, we have our folder here. We will okay, so I want you then to make a subfolder, and so this would be CCA1. Okay, and I just hit escape, but that way we can organize everything. Okay, and then now all the sequences can go here. So I should when you start working on that, save each of the files here, and then it'll keep everything nice and organized. Okay, so there you go. That's what you need to do. So it's very straightforward. Go through each of these sequences here. Do as many as 15, checking them in Target, and let's see what gene they are. Okay, and then next, if you choose to help us out, even though the program officially ends on Friday, then the next thing we're going to do is align for error correction, and then we will then take those corrected sequences, each one for each variety, and we will then align them to the reference, which is Citrus sinensis, or the sweet orange, and we will then prepare everything for uploading to the database, because this sequence now looks really good, and we will be able to upload to GenBank. So, and as much help as I can get from you guys, the easier it will go. Okay, so get to work on this. We will meet on Friday and talk about progress. It'd be great if we're done by Friday. It really won't take you long. Put on a movie and analyze sequence. Okay, and then Friday I'll have more instructions, if not before, on what to do for the next 2 steps. Okay, great. Talk to you on Friday. Bye.